Hey, what's up, everyone? Good morning, or afternoon, or evening, depending on what your schedule is, or anyone from outside the Moncton High community, whatever time zone you're in, whatever year you're watching this in. Want to welcome everybody inside or outside the Moncton High community who may be watching this. But this is especially for the pre-calculus 12B students of September 2020. All right, we're about to do this. Okay, we have a warm-up question here, which is just a review of some things that you did late last week. So perhaps maybe what you might want to do is just hit that pause button and attempt this question on your own, and then watch the video to see if you completed things correctly. So if you're in that category of student who knows what they're doing and is ready to get started, then maybe that's a good idea. To the rest of you who may need some extra help with this, I'm going to do this step by step. So first of all, this is a degree 3 polynomial, which we learned how to factor. If you want to think back to all the types of factoring that you learned in the first week, this does resemble grouping because there are 4 terms. But if you tried grouping, which is an excellent idea, by the way, to try any of these shortcut methods that we learned in our first week together. But if you tried grouping with this one, you would be unsuccessful. Okay, this one cannot be factored using grouping, but certainly worth a few seconds of your time to try it out and see. So because we cannot use any of the shortcut methods, okay, we have to go through a longer process which involves some trial and error, involves some synthetic division, some factor theorem, some integral zero theorem, a whole bunch of these little bits and pieces that we learned last week. So let's do this. Okay, so the very first thing you want to do is you want to narrow down your possibilities for trial and error. So you think about all of the possible integer roots. Right now you're thinking there's an infinite number of integer roots, but of course what happens here is I can reduce them down using the integral zero theorem. I can reduce my possibilities for roots to be just the plus and minus factors of the constant term 8. It's a negative 8. Negative 8 is a constant term, but the negative is not really important for possible roots because our possible roots are both positive and negative anyway. So I take the factors of 8, which are 1, 2, 4, and 8. Those are the numbers that divide evenly into the number 8. And then I just start trying these numbers one at a time until I get one that works. So I'm going to try x equals 1 first. And so I plug in 1 for x, and I'm trying to get a remainder of 0. If my remainder is 0, that means it divides evenly. So you would do the order of operations here, and I will skip that step. You'll do exponents, then multiplication, and all that sort of thing, okay? But you're going to wind up with negative 20, which is not what we're looking for. That's fine. Let's try negative 1. And if I try negative 1 here, I don't think I'll be successful here either. So try negative 1, and again, I had a few questions the other day about negative numbers to the power of things. If you happen to be using your exponent, your calculators for these, make sure that if you're using exponent buttons on your calculator, be sure that if you have a negative number to the power of something, that you're using brackets around your negative number, just to make sure you have the correct answer. This time out, I will go through all the steps. So negative 1 cubed is still negative 1. Negative 1, and that's supposed to be a squared, by the way. So that's a square, and negative 1 to the power of 2 is positive 1. So all I did in that step were the exponents. And then I can do multiplication here. So you can see that this is probably not going to give us a 0. This is going to give us 18. That's not what we're looking for. Okay, when we divide, we get a remainder of positive 18, which is not what we're looking for. Okay, let's take a look at x equals 2. I promise you I won't make you go through 5 or 6 numbers before you get one that works. Generally the 1 or negative 1, or if not those, then definitely one of the 2's will work. I believe this one does work. Okay, if I put in a positive 2 for x, for each of the x's that are involved, and then I do the order of operations here, I should get a remainder of 0. So I get 3 times 8, which is 24. I get I get 2 squared, which is 4. That's a 28. And then I have minus 44 minus 8. And it looks like here, okay, I'm going to get 52 minus 52, which is 0. And that's what we're looking for. So let's just write this out in words. Okay, you don't necessarily have to write these statements, but it's good to kind of get your head around all the different terms and things of that nature. Okay, x equals 2 is a root. Okay, we plugged in positive 2 and we got a 0 remainder. So x equals 2 is a root, which means also a solution, a 0, an x-intercept. You're going to see later this week that that is going to be one of the x-intercepts on your graph. Okay, so we have x equals 2 as a root, which means the opposite, x minus 2, is a factor. So we have found one of the 3 factors. This is a degree 3 function, so we're expecting 3 different factors. So basically what we have here, okay, is if we want to take a look at this question once again, this 3x to the 3 plus 7x squared minus 22x minus 8, we have already found in the previous step that x minus 2 is a factor. Okay, so we have x minus 2 as one of the factors. We want to see what's left over. We're going to have a degree 2 function left over because we have a degree 3 and we found one of the factors. So how do we know what's left over? That's where synthetic division comes into play. So with synthetic division, we put the number of the factor up in the corner. And be careful, okay? That's a very confusing part of this process, is knowing when to change the number and when to keep it the same. Synthetic division is always the factor number. When you plug in numbers for x, it's always the opposite of the factor. It's the root number. Okay, so I'm going to put in my my coefficients here. And I put them across. It's already in descending order, so we're good. And then I'm going to go through the process of synthetic division quickly. I'm going to get a 0 remainder. I've already figured out that it divides evenly, so we're going to get 0 remainder. And then going through synthetic division here very quickly. Okay, we've already have learned this. All right, so you're going to end up with these numbers right here. And more importantly, okay, we're going to wind up with 3, 13, and 4. So, and again, feel free to pause this video at any time if you think I'm skipping some steps here, just trying to make things nice and concise. But you can see right here that I now have a factor of x minus 2, and I'm left over with 3x squared plus 13x plus 4. Now I'm down to a quadratic, which I can factor using the traditional methods. Okay, I can use decomposition to factor this down. And once again, okay, just like in class, I'm not actually going to go through that process. Okay, we've learned decomposition weeks ago, and we've had lots of practice doing it, and it's on your assignment 1 that you all did very well in. So you can just do it off to the side if you like. All right, I'm just going to give you the solution from here. I'm going to skip the decomposition step, and we're just going to get right into the answer here. All right, and we're going to get 3x plus 1. And the other factor is x plus 4. And now we have found our 3 factors, and we have completed this question in full.